record to the cloud. Great.
Well, welcome to the November 2nd, 2021 session of TangerineSDR and Hamsci technical session. My name is Dave, KV0S, and this week, well, right now I've been spending the whole day on a Zoom video conference of silviculture professors from around the US, and including tomorrow we're going to have talks from a professor in Hawaii and a professor in New Zealand as well. So the other interesting thing I ran across this week was a set of videos about what it's like to live at the South Pole. And I thought of Nathaniel when I he even walked by a room and said, "Oh, in there's the ham radio stuff." And he showed the desk in the lab of where Super Darn was set up. So those both perked my ears when he talked about that. So otherwise, I've been working on code and some radio code for the Raspberry Pi, trying to get it working on mine. This is code that Phil has been working on, Phil Karn, and it's not ready for prime time, but it's actually a quite good package. Just needs lots of cleanup, and that's what I'm helping with. So that's it for me. Next on the list is Nathaniel. Oh, well, Nathaniel, just go ahead.
Sure. Yeah, W2NAF. Thanks a lot, Dave. It's been a busy week as always. I've continued working with Bill Engelke to work on figuring out plans for the Hamsci workshop. So we are continuing to work on that. This weekend, let's see, I ended up not feeling too well on Friday and Saturday. So I kind of lost a couple of days there, but then I did pull myself together and I was able to participate in CQ Worldwide a little bit, which was fun. So I made over 250 QSOs. So not a huge effort, but it was still fun. And one of my observations from CQ Worldwide was I looked up a lot of the people on QRZ, and I'm pretty convinced that what you're expected to do as a ham radio operator is buy a small Caribbean island and invest a lot of money into a multi contest superstation. And that is what I believe is the norm, or what an average ham radio operator is supposed to do based on the types of people I talked to in this contest. So whether or not that's true, I guess remains to be seen, but that's my impression right now. So back to Nat.
Well, thanks a lot. And next on the list is Dan in for XWE. Go ahead, Dan.
Thank you, Dave, and good evening, everyone. As I had mentioned a little bit earlier, I've spent most of last week working on getting the Pi HPSDR package and WSJT package working together, mostly issues with pulse audio and a few other things. So the Pi 4 supports WSJT X and most of the packages in it, at least the ones I've tried, very, very well. Anyway, that's about it from here. It's kind of chilly in North Carolina right now.
Yeah, it's gonna, our weather is becoming cooler and cooler. I think we'll have our first below freezing night here soon. Let's see, next on the list is Dev KC3PVE. Go ahead, Dev.
Hello, good evening, everyone. So we have a good start of the week today. Other than that, I don't think I have much to report this week. Thank you so much.
Very good. And next on the list is Bill, AB4EJ. Go ahead, Bill.
Just a few things going on, as Nathaniel mentioned, working on trying to work out the kinks and trying to see if we can move the Hamsci workshop to Huntsville, Alabama, and some things related to that. I think I had a fruit GPS board smoked, so I ordered a new one, but I haven't had a chance to hook it up yet because it requires soldering and various things, and it just came in the mail. And also have a preamp that came from John Gibbons, which he's looking for me to test. Haven't had a chance to get to that, and I'm getting ready to go tomorrow to Orlando for my son's wedding celebration thing. He got married about 2 years ago, but this is the first chance we have to get together and have a thing for him at my daughter's house in Orlando. So not too much has been accomplished here. Worked a little bit on analyzing PSK data for looking for TIDs in PSK data, but that is not really ready for prime time yet. So it's very little else to report. So back to Ned.
Well, fine business. Next on the list, we have Dave KD0EAG. Go ahead, Dave.
Hello, not much to report here. I've been working on things, but nothing to tell. Back to you.
Well, fine business. And next on the list is David Waugh, KE8QEP. Go ahead.
Hello, everyone. I guess Bob, I think, posted, or Bob KD8CGH posted our results from our magnetometers, which are put about 10 miles apart. And they seem to be tracking fairly well. And he wrote a little program that can both graph them and I guess graph 2 separate stations at a time. And Jules has been helping me quantify the 60 hertz signal that my magnetometer is picking up. I guess he's doing most of the work. I'm just trying to understand it. But I think there's been some progress there. That's it here. Back to Dave.
Well, fine business. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Got my whisper transmitter on the air. Was glad to see that KV0S was one of the stations receiving me.
Hey.
And the more I dig into the number of whisper databases and how the data is analyzed and stuff, I guess I've probably achieved immortality with having my call sign in some of those databases now. It's the closest I'll ever get. So that's it. Back to Ned.
Yes, I've been on having a continuous whisper beacon since maybe 2012 or something. So I remember Scotty mentioning he looked at the cover of QST when they had it about whisper, and my call sign was in the middle of the map. So anyway, he may have a story about that. Let's see. Next on the list is James. Whoop. KG4 DSG. Sorry, James.
Well, no problem. Evening, Dave, the group. Not much to report here. I do have a question for Dave. It can wait, but it has to do with Phil Karn's software.
Yes.
I'll wait till later, and then
okay.
It's not real important. With that, back to Ned.
Next on the list is Jay, WB8SBI. Go ahead, Jay.
Well, excuse me. Yeah, good evening, everybody. Not really much new to report here. Over the past weekend, I did participate in the annual AMSAT Space Symposium. And one of the things that you may be familiar with, the late Tom, Kilo 3 India Oscar, who was one of the powerful figures behind AMSAT and science in general. And there was a very, very moving commemoration of him by several of the people who knew him and detailed his accomplishments. And one of the things that would have been of interest to this group was that he was part of the group that founded the study of very long baseline interferometry. And that was just fascinating to hear his part in the VLBI science. Otherwise, not a whole heck of a lot new here. Hope everybody else this past weekend was CQ Worldwide Sideband, and those who participated, hope you had a good contest. Other than that, nothing much here. Take care, everybody. Back to Net.
Okay. And next on the list is JB K8OS. Go ahead. Muted.
Okay. Good evening, everyone. Thank you so much. Let's see, I don't have a lot to say. Last week, I think I exchanged a couple emails with Nathaniel regarding some ultra large scale FFT technology that I can offer if you're going to be doing really big FFTs. For example, if you want to do spectral analysis of really long data stream, you would be able to do this. And so in the conversation, I think it was me that decided that I would put together a GitHub project and make that available if at some point you decide you want to use this. I can run it on anything that has GPU fabric, AMD or NVIDIA. I've even run this stuff on a little Jetson Nano that has a tiny Maxwell GPU on it. But in principle, I can, a billion point FFT is almost trivial. I can do this I can do these transforms I map it to a bank of GPUs and use supercomputing techniques, scatter-gather techniques to do this. I don't hear much talk of the data on the data analysis side here, so I'm not sure if this is going to be useful to you once you get to the data analysis part, but I'm going to make it available. And then pretty rapidly, I'm going to turn my attention to wavelets, a wavelet-based type analysis, of this data, which I think might highlight some very interesting phenomena, once we're at that point. But at any rate, I don't think you need this quite yet, so I'm going to remain in a listening mode. Other than that, I spent a lot of time on 10 and 15 meters this past weekend, and that's about it. Thank you. Back to Ned.
Well, very good. As you can tell, we're a mix of longtime hams, engineers, and academics. So each of us have different skill sets, and I really appreciate what you're offering because I see a real value for tools like that for some of the things where our potential products of this outcome. We're still fiddling with the hardware parts at this point, but there's a lot of software that needs to go behind it.
May I ask a question?
Sure.
So, would you be willing to give us a link to your GitHub?
Yes, of course. I'm going to make all this. I'm going to write it up. This is a technology I've been sitting on for a few years. Originally, I was trying to sell it into corporate America, which is it's an entrepreneurial thing. It's kind of a crazy scene, but I never published it. So I'm going to write it up. I mentioned to Nathaniel, I'll write it up. I'll make the paper available to you first, so that you can review it, see what I can do with this. With these ultra large scale FFTs, give you some performance data and what have you. And then at some point, perhaps it will resonate, you'll find a specific use for it. And of course, I'll provide a link to the GitHub page so that you can clone it. That's the whole purpose of it.
Yep.
So yes, I have those things to do, but I'm going to go into low bandwidth mode on that because I don't see a current need.
Yep.
So, and then once everybody is filled to the brim with ultra large scale FFT, I'm going to bring out my wavelet technology next, which is, how should I say, wavelets sub-10 FFT or Fourier transform, and for looking for phenomena that map in a certain way to the time frequency tiling, if you will. You can pull out really interesting phenomena with wavelets. And so I'm kind of drooling to, what a word, I'm kind of drooling to kind of get my mathematical teeth into the data once you're generating it. And the bigger, the better. I like challenges. So like I said, 1 billion points is nothing.
Okay. Well, I think we're going to have a data sets to work on as soon as we get some receivers going. So
sure.
So let me continue down the list. So next on the list is Jim K4BSE. Go ahead, Jim. Mute.
Thank you. Good evening, all. I didn't get a whole lot done. I was out of town last weekend at a family wedding, and I have been fighting a septic system pump problem. So that's kind of had me away from the shack recently, and not quite done with that yet. However, I did get my Grape 1 back up and running a week ago tomorrow. I was getting daily crashes because apparently the micro SD card was just shot. It couldn't take the repeated read and write. So took the recommendation on a new card, got it in, and it was last Tuesday they got the system running, about 2100 UTC. And Wednesday, I discovered that for some reason, FLDigi had decided to go off and tune to 999 hertz as a center frequency instead of 1000 hertz. And so all my data was offset. Got that frequency problem fixed on 828, and on 829, I got good data until about midday UTC, which was about when I was going on the air some that morning on 80 meters. And it was about that time that FLDigi decided to retune again, real low. And since I left town a few hours later, I didn't notice it until I got back Sunday. So I had no data on Saturday. Sunday, I got home and caught the problem about 2000 hours UTC and got it fixed. And today, for the first time, I actually got 24 hours of good data. The first time I got this up and running again. I'm looking forward to converting this over to the RFD mod or the RF data. And I have all the pieces for that finally. Hopefully I'll get that done later this week. Sorry to take so much time. Back to Ned.
Well, very good. And next on the list is Joe W7LUX. Go ahead, Joe.
Okay, you caught me a little bit early. I just got here a few minutes ago. Been pet setting for the girlfriend. Not much to report, but I do have a screen full of graphs, and I don't really see anything that corresponded to the impact of a coronal mass ejection. So I don't know what to say, except has anybody else seen anything that might indicate that we got hit by some charged particles from the sun, result of that flare on, I think, the 28th.
I was actually talking to Tamitha Scove earlier today, and she was talking about it. And we actually did not get hit earlier this weekend. It did actually just show up earlier today, a few hours ago, maybe, I don't know, 6 or 8 hours ago. And so we're just starting to see the effects. but it's actually a very minimal effect because it's a rather slow speed solar wind stream, and the interplanetary magnetic field is northward, which means that you don't get maximum reconnection between energy transfer between the solar wind and the Earth's magnetosphere. So we did just get hit today, a couple days later than was expected, but it's really not that dramatic of an impact.
I don't see a whole lot at the end of yesterday or today's graph. So I agree. Okay, I'll keep looking, but hey, thanks everybody. Appreciate the reports.
Yeah,
I don't see anything dramatic on today's data.
Yeah, I'm looking. We're at just a KP of 4 right now, which is not dramatic.
Okay, is there some way to look at the results of the grape receiver before having to wait a whole day for the graphs to show up?
Probably. Because it's constantly recording the data to a file on there, and
right.
you can probably run the plotting script manually before it automatically runs the plotting script at night. Okay.
Thanks, Nathaniel.
Sure.
I'm done.
May I ask a question, please, or make an observation?
Go ahead.
So, being an avid DXer, I'm watching the various solar indices on QRZ.com, for example, and sometimes the government websites. I'm seeing proton and electron fluxes higher than anything I've ever seen before. Of course, I haven't really watched these things, even though I've been a ham for a long time. I've only been watching this for the last few years, and I'm surprised that under these circumstances, you're not seeing qualitative differences in the noise that you're looking at. And you're saying you're seeing no indication at all?
I don't see anything remarkable. There's a blip in the data for the 31st from about 8 until 1000 UTC. The shape of that I haven't really seen before. It's kind of a smooth increase over a period of 2 hours, increase and decrease. Usually it's much sharper than that, but I don't see any indication. I'm monitoring WWV on 10 megahertz, so that may have something to do with it.
Also, if you're looking at like solar energetic particles, if you just look at those counts, those are typically going to get funneled into the polar cap or the auroral zone, and they won't be impacting directly at mid latitudes or even mid latitudes and low latitudes. So you're probably not going to see as much of an impact there. If the interplanetary magnetic field turns southward, that's when you get magnetic reconnection at the day side, and that's when you really get energy going from the solar wind into the magnetosphere and causing more impact to, say, DX operating.
I'm just it's just this is exploratory science. It's real science. So we're trying to figure out what correlates with what, and with all the energy in those protons in particular, I would expect at least some marked shifts in the noise floor. But, that's just a guess.
Yeah, no, I think a lot of that, those particles, the magnetosphere protects us from them. Sure. And so if the solar wind or if the interplanetary magnetic field isn't in the correct direction to give you reconnection, those particles just aren't going to enter into our magnetosphere the way they would otherwise.
See, you're speaking of the magnetosphere and the geomagnetic effects. I'm speaking of the noise. The ionosphere is a plasma.
Right.
And I would expect with all those extra particles, there would be some resonance effects.
But what I'm saying is the magnetosphere is shielding.
Sure.
You're still like the magnetopause is 10 Earth radii away from where the ionosphere is.
Okay.
So So if you're having those particles hitting the magnetopause and getting deflected around the magnetosphere, they're not going to make it down into the ionosphere. And so you're not going to see that noise.
So you don't expect any significant correlation between proton electron fluxes and the things that you're looking at?
Not at mid latitudes when you have let's say northward IMF BZ.
Okay, thank you.
And actually, if you here, I'll put this link in the chat right here. If you click on solar radiation storms, you can see they have a list of scales. And if you look, and it tells the effects. So if you were to look, hold on. Here you can see for the solar radiation storms, when it says even for extreme other systems, complete blackout of high frequency communications possible throughout the polar regions. So it's more possible in the high latitude regions than at the mid latitude regions, because those particles are going to get funneled along the magnetic field lines and into the aurora and into the polar cap.
Yes, but even so, I'm okay. I'm not going to argue this. But it would seem to me, even if the effect was that the observed effect of these fluxes were at the poles, we're talking about an ionosphere that reflects high frequency radiation for very long, very long paths. I would expect some shifts in the noise.
Yeah.
In the shape of it, the variance, the mean, the variance, the statistical moments of the noise, I would expect to shift worldwide.
Mm-hmm.
And I would expect it to be observable, but that's.
Yeah. I mean, and maybe if we look enough, maybe we can find that.
Yeah. Just a guess. Thank you.
Well, let me finish with the roll call. And I think we're to Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I was actually pretty busy this week. So I was talking about last week. I was having trouble with the timing system of my VLF signal using the new audio injector isolated sound card. So as a last ditch effort, I put together an opto-isolator circuit that interfaced the pulse per second signal from the GPS into the sound card. As it's mentioned in Paul's documentation, that noise that gets coupled onto the PPS from the GPS rails makes its way onto the PPS signal and can interfere with the centroid timing method. So he recommends in any of his three timing methods to use an opto-isolator to clean up the noise a little bit. And I didn't notice any sort of appreciable difference. I was able to get what seems to be optimal settings for VT time. And I've been noticing that the same thing is that as it'll detect centroids. And one of the measures that it takes is the PPS MAD, or mean absolute distribution. And what it does is it notes the time between consecutive centroids or pulses, and that number should be around the same thing every time. If that number deviates, then the BT time program goes into the setup mode again, trying to find the pulse. But every time I could get you know, 5, 6, 7 pulses, and then there's like an 8 or 16 millisecond jump between the last centroid and this one. And I've been seeing that in all my experimentation. So I think my timing system is optimal, that there's something else going wrong. And this sound card does not use a crystal. It uses an internal PLL that's probably clocked from the bit clock. I don't know if that has anything to do with it, but there's something going on with the sound card. I was adjusting the sound card period and buffer settings, and I still couldn't get it. And in the meantime, I noticed that my GPS time was 20 years off, which was quite a surprise to me. Initially, I thought, well, maybe it's the GPS rollover, and you know, it's a brand new Trimble timing receiver. It's their latest generation, so it shouldn't have that problem. So I contacted the dev of GPSD, and he informed me that that was an actual bug in the code. So I updated the code, and then there was another bug specific to my setup that cropped up on the latest version. So what most people do is they use, connect their GPS serial port into the Raspberry Pi serial port, and they connect their GPS pulse per second signal into one of the GPIO pins. Since I use my serial port as a console port, I don't have that kind of configuration. I use a USB serial converter. So there was a bug in the latest version that did not allow it to detect certs and clears from the pulse per second driver. So what I had to do is I had to revert to the previous version, and everything is working okay. So now that my GPS timing is working okay, I'll continue to work on that sound card. It's looking like I'm going to have to go back to the original one. I know at least that worked and worked well, but we will see. Other than that, back to the net.
Okay, and next on the list is Jules K2KGJ. Go ahead.
Okay, good evening, group. Besides time spent this week on continuing prep for winter around here, I was able to do some additional work with Dave Wog on a fast single-axis sampling program using the RM3100 to actually take samples every 3 milliseconds and thereby be able to see 360 hertz noise that appeared on any particular channel, one axis at a time. That worked fairly well. That was with Raspberry Pi 3B Plus, and that's a 3 millisecond per sample. The other thing I've been playing with is using a GPS DO for 1 PPS timing pulses that would drive the interrupt GPO lines on the Raspberry Pi 3 for precise or more precise timing of the magnetometer measurements in order to get the full 86,400 measurements, that is per seconds in a 24-hour UTC period. And that seems to be working. We'll continue. I had a little problem with an antenna placement on the GPS DO, but that seems to be taken care of. And the other topic this week was a discussion with Dave Witten on, and then I forwarded an email to Nathaniel, to Dave Larson, and also to Hyomin Kim regarding maybe we should start talking about timing requirements for magnetometer measurements and reporting, and how accurate and precise does that have to be in terms of time? What type of time intervals do we really need to deal with? and so on. So that's a discussion for hopefully for the near future. Back to Ned.
Well, fine business. And I did get those messages. Next on the list is Michael, AA8K. Go ahead, Michael.
Well, thank you, Dave. And, greetings to everyone listening and thinking about, where is it? Whisper. I dug back in my files, and here's me on Whisper in 2011, about 10 years ago. I was using the HPSDR Penelope barefoot, which was about a 1/4 watt output, and it was a little less populated back then. Back to you, Dave.
Yep. And I'm not on there. So let's see. Next on the list is Scotty WA2DFI. Go ahead, Scotty.
Okay. Good evening, Dave and the group. Not a lot this week. Did exchange some emails with Joe about mounting the magnetometer in the pipe. I think I'm kind of favoring the foam pipe insulator approach, and we'll see how we can if we can get that to work okay. Also, I did finally answer your email, Tom, about some of the questions that you had, and not feeling really good this week. So, although we got good news, we are breaking ground on our house a week from today. So finally, after 18 months of fighting with city permits and everything else, we're going to get the dozers up there and start moving dirt around, playing in the dirt, so to speak. So that will be exciting. Be truly a house designed around radios, which as it should be. So back to you, Dave.
Well, fine business. And next on the list is Todd AD0RR. Go ahead, Todd.
There we go. Let's see. I've had my DRF grape running for a little over a week. I don't remember exactly when I turned it on, but so far I have just shy of 20 gigabytes worth of data, which means that I probably have about 3 years of storage here. That's the good news. But 20 gigabytes a week times however many grape stations kind of infers a robust file upload infrastructure that's going to have to be in place if we're going to be gathering, if we're going to hold this much data and we're going to centralize it. That's going to be might be kind of interesting. And I'm working on my own I2C extension boards, waiting for the Tapper boards, but I'm building some using CAN bus, which ought to drive the distance to where I'm going to put the magnetometer. So anyway, I'm getting that board finished up so that I can start playing with that. So anyway, that's about it. So back to Ned.
Yes. Bill Engelke is the person sitting at the end of that pipe. So it's his job to figure that out. Next on the list is Tom N5EG. Tom, somehow you're back on the bottom of the list.
Who knows how all this works? Been a busy week. I modified the FPGA code to add 5 I2C and 1 SPI interface blocks, and that synthesized correctly. We're up to right about 50% utilization of the logic elements now, just with the processor, memory, DMA, gigabit Ethernet, all of that kind of stuff. Scotty, I saw your email reply. One question I didn't see an answer to. On the receiver, the I2C control lines are called SPI, and the SPI control lines are called I2C control. Was that intentional, or is there perhaps a flip in the labeling? I wasn't sure about that.
Oh, I'll have to go check that, because there wasn't anything intentional to flip them, but really on the SPI lines, when we have 4 lines, we have a data in, data out, clock and select, we could really program that to be two I2C ports if we want, because all the IO pins are all programmable. So whether it's called SPI or whether it's called I2C, doesn't really make any difference as long as we make sure to program the pins the right way for however it's connected.
Yeah, the SPI is the 3-wire version, so it has a bi-directional line and a clock and a chip select. So, okay. So for now, I tried to deduce which FPGA pins on the development board were which interfaces going out to the receiver module and the clock module. And I sent you a table of what I thought was.
Yeah, and I have yet to get to look at that, so.
No problem, no problem. After doing everything, I now have to manually create software drivers for the project, because the automated way was just for the example program for the socket server that comes from Altera. So now I have to manually do that. And I'm not quite getting the expected results, and I'm still trying to track down any discrepancies before I've got a recipe for manually building the whole device driver chain for the device. So working on that, and that's it for the week. Back to Ned.
Well, fine business. And unless somebody speaks up, I think I've got everybody on the list. So we should be
Did you
open
get Joe?
I think I got Joe.
Okay.
So we're open for discussion.
Yeah, one thing I forgot to mention was that we're getting prepared for Hamcation in Florida, in Orlando in February. And we're going to have a kind of a tech alley over by the Tapper ORI booth in, I think it's the North Building. And we're going to have a whole day full of seminars, which will be kind of in between the DCC technical level and the Hamvention technical level. So they'll be a little more advanced than your average just Hamvention talk, but they won't be as technical as DCC. So we're looking forward to, I think we're going to have about 5 talks scheduled for the entire, we're going to have one room for an entire day. So look forward to doing that.
Good.
Look forward to having an in-person one again after all these years. Seems like forever.
That will be really good.
Yeah.
Only missed 2, but it just seems like forever. And we had a Hamfest this last weekend, which was just about killed me moving all the junk out to try and clear out some of this stuff here. But it was great to actually go out and be at a Hamfest again. And it was pretty good turnout too. So you got to see a lot of people, a lot of social activity that we missed over the years of not having them.
Yeah.
It is really good.
Dave?
Aside from the fact that I got a nearly new Hammerland receiver out of the deal, it was collecting old receivers is a disease, you know.
Yes. James, do you have a question?
Yeah, I had a question for you. You say the last couple of weeks you've been working on the Phil Carnes. I assume that's the multicast software he did at DCC.
Yes.
Did he ever set up a proper repository for that, or is he still running that off a laptop?
It is a web link to an RCS repository. Now, do you remember RCS? Was popular in the 70s and 80s.
Okay. Is that what he's working from?
Yes.
Okay.
And I wouldn't really worry about compiling it yet, because right now it compiles, but it doesn't, there are some missing functional pieces. And
yeah,
what I'm doing is building it to a point till it breaks, then reporting those issues to him, and he goes, "Oh yeah, I need to fix that."
Either fix it or move the code that he's working on somewhere else.
He's been working on a machine for a long time, and it has a lot of hidden libraries that he doesn't remember to put in.
It's
that
Git.
process. Huh?
He needs to learn Git.
Well, Michelle Thompson actually put all of his code on Git. And as far as I can tell, it's identical except for the last couple changes.
Yeah, but she's not working with him as closely as you are if you're reporting things that don't
right
work.
now I get to talk to him about once a week. Not sometimes it's once every 2 weeks, but at least he's responding to me.
I assume that link that he gave on the talk is the link, but
Yes.
the same link you're working from?
Yes.
Okay.
But you really have to be well versed in multicast, and he uses a lot of services. You really need to understand System D really well, and I mean it's a bunch of layers.
Oh yeah.
And so you really, it takes a while to get your head around it if you haven't worked with that. I'm well versed in regular Linux, Unix for years, but some of these things either are newer packages or I hadn't spent a lot of time worrying about them. So I've been doing an awful lot of reading in the last month. And a lot of our RFC documents, because Phil really likes RFC documents.
Yeah, I grabbed a copy the week of the DCC. I had a suspicion that he was working off another set of software. It sounds like he may still be working off another set of software. But as long as people are getting error reports back to him, I guess that's as good as you can expect.
So his normal computer to work on is a Mac.
Oh, okay.
And so he works there, but he's been working a lot on Raspberry Pis recently as support devices for a dongle. And it then goes into the multicast system. Yeah. And so what I'm trying to get to the point is where you can have a dongle, a service program, the radio program, and you can hear something out on the Raspberry Pi. And we're not quite there yet.
Okay. That's all I wanted to know. Thank you.
And I'm trying to write all this stuff down as I work through it so that you guys don't have to go through that. But it is a very impressive piece of software. Once
I thought it was interesting when he presented at Albuquerque.
Yes.
And then he did the latest one has made major improvements. So
yeah, I had paid attention to the 2019 or 18 talk, got excited, but couldn't figure out very much. And then I got re-excited in this last round. And then I figured the best way to get it working is to interact with Phil and see if I can. And he's
and this is Bill.
Interested in keeping it all going, but I take it that he's a busy guy and he's got other things, so he doesn't answer all the questions all the time, but he does a good job.
Okay, very good. Thank you.
Yeah, and JB, I'd be interested to talk to you about maybe trying to put some of your algorithms into FPGA code rather than.
Oh my goodness! Yes, I was a senior researcher at Xilinx Labs back in about 15 years ago in South San Jose. So anyway, FPGA, sure. The only question I have right now is why map heavily vectorized code that matches GPUs so well and use FPGA to create the same thing when you have something like a Jetson Nano that, costs less than $100 and you can run it. Anyway, that would be my first question. But if indeed you wanted it on FPGA, it could be done.
Now, you and Phil Harmon would get along great.
Well, I tend to also have that attitude, Scotty. So,
I do too.
But the big issue here is getting from the A to D into something that you can stream into the Nano.
And I have some slightly larger NVIDIA setups like the Xavier and stuff that might be really interesting to play with.
Yeah, I have the Jetson AGX, which is for that family. It's the monster, and it is very powerful.
Yes.
But you know, I have a lot of flexibility here. This is it's massively vector code. FFT is a butterfly type algorithm. You know, very, very vectorizable. So, why would you want to go FPGA? Let me ask that.
Well, because we have an FPGA to start with.
Which FPGA do you have?
We have a Max 10,
Max
10M50,
10.
Altera.
Okay.
Intel.
Oh, all right. I actually I worked for Xilinx, but I preferred Altera. The tool's much better. Okay, a Max 10. Yeah, that's a pretty big one, isn't it? How many LUTs?
50,000 LEs.
Okay.
So
it's the little one.
Forget how many ALMs that is. That's 12,000 ALMs or something.
So
just for JB's information, is previous projects we were working with the Cyclone series.
Sure, I've used Cyclone for a totally different purpose, but
yeah,
sure.
Scotty built some Cyclone 4s and Cyclone 5.
Yeah, they're good devices. And as
radios.
I said, I like those tools. So again, my question is, so this. What do you have in mind that you want to do with an FPGA, with say big ultra large scale FFT running on an FPGA? What do you have in mind? What do you want to do?
Well, currently we don't do the FFTs in the FPGA.
Okay.
So I was curious as to what the algorithms look like.
Yeah, you could definitely do it.
And you know how they would fit in, and maybe there's a point where you want to do the FFT in the FPGA. Right now, we aren't doing it that way, because we filter it down, and then we let the DSP processor, general purpose processors, do DSP on a small slice. So that's been right. But that's been the MO for SDRs since the beginning for a long time.
Sure, I
Only
understand.
now things are changing because you've got these new processors,
right.
the GPUs that can do this, which 10 years ago you didn't have those. So this is the way we did it then. And this is like I asked Gerald one time, well, how come you waited until 2004 to found Flex? And he says, well, before about 2000, the PCs weren't powerful enough to do SDR. Mm-hmm. So you just couldn't do it.
Sure.
So JB, have you ever looked at under the OpenHBSDR project, a set of code called DFC?
No, I have not. I'm not familiar.
I'll send you a link to that.
Okay.
Scotty mentioned Phil Harmon, who worked on that. He lives in Australia, but he worked on a project with John Melton, and they used the original Jetson. It was 192.
It was a TK1, wasn't it?
TK1. And what they did is they took the signal out, put it in that original Jetson, and then worked with GPUs. And you might be interested in that piece of code. That's the one attempt. They ran into some issues along the way, had grand plans of making other versions of it, but the project kind of fell on the floor.
And what was the goal? What was the technical objective? What was he trying to do?
He wanted to reduce the dependency on FPGAs. He didn't like programming FPGAs.
Well, a few people do. It's pretty VHDL and Verilog.
Yes,
a lot. It's a whole shift. It's a very distinct. I can't even really call it programming. I call it hardware design. But why not just stream the data, use socket, stream the data to a workstation?
Yes. And that's essentially the model they had.
Oh, okay.
You can do that very well, and it worked well too. I was at Friedrichshafen when they demonstrated it. And it's just that with the TK1, they really only were able to do, I think, receive only, and which is, of course, for our purposes here, that's pretty much what's interesting. They were able to put 7 or 8 receivers in I think 6 or 7 in a even with the TK1, which is, you know, tinier than the Nano, I believe, and they were able to do quite well with it. But it's just that no one had the time at that time, or the motivation to really push forward. Also, they did have to go through an FPGA to get, you know, they went into the FPGA socket on the TK1, but they had to, you know, because they had to read the ADDs they had and stream it in as a CERDES stream. But then the TK1 did the rest. But the hardware with the CERDES lines was all pretty expensive at that time, which it's not now.
For the CERDES, right? Yeah, FPGA is the natural for that.
Yeah, but the tools we're working on here don't have CERDES and don't make the Max 10 doesn't have any of that sort of thing. But it is a much more flexible and probably future-proof way to go about things. And you can scale it, you know, in over orders of magnitude of power for application.
So do you have an architectural concept for this? We could just, I mean, a block diagram that we can all speak to, and because I'll put this wherever you need it, you know, so, but there has to be a rationale for it. If you want me to bite into FPGA design, which I'm pretty familiar with, but it's his own world.
I wasn't really asking you to do that. I was just curious because that's what I do. FPGAs is what I do also.
Okay.
So, and I don't do GPU programming, so I'd be interested to see how that would move between the two. So
it would work quite well, except that understand if you're going to do what the GPU does on an FPGA, you're going to basically be constructing a GPU.
Yes.
So
I sent a link in the chat to John Melton's DFC code.
Okay. I'll take a look at it.
And John Melton, I don't know if you have ever met him or
no.
He was a programmer for years with Sun Microsystems. And
sure.
He ended up, he's English. He ended up working for Oracle at the end of his career. And but he did a whole bunch of programming on the Open HPSDR series. And this was the project where he did build some GPU code into the process. At that same, if you go up above the DFC, you'll find the DSP library that we use and some Linux GUI code as well. Lin HPSDR is also there.
Okay. All right. So I have that link. I will go through this code. I'll take a look at it.
This is specific to the Open HPSDR boards. So it speaks the radio protocol coming in is that protocol.
Okay. It's not something I'm familiar with.
Yeah. So several of us in this project were on that project for a year. Well, Scotty got me started in it back in, I don't know, 2006 or 7, somewhere in there. But there are bits and pieces. Some of this code is also on the Tapper GitHub site. But if you want to find something ask me, because I can help you find it a lot faster than you probably can.
Oh, no problem. I would be happy to.
It's not well organized, but it's all there. Because what we did is we had an SVN for years, and then we did kind of a straight SVN to GitHub.
Oh, really?
Convert, and it looks very un-SVN, un-GitHub-ish. Now, this side of John's, he built it on GitHub. So
please just give me in a sentence or two, tell me what's happening with this code. What's the Gazinta? What's the Gazauta?
So the main code is receiving from, so you have an FPGA that's taking signals through an ADD. It's making packets of some length. And then they're using the GPU to build large overlap and save kinds of bigger data streams.
I see.
And apply FFTs to those.
Okay.
So it's a lot like the stuff that you've been talking about.
Okay.
The code is, I don't know when it was last updated.
Now,
6 years ago was the last time people touched it.
Okay, I just want to interject here that what I had in mind originally, which may not be the model that you actually champion or need, I was assuming that you might want to generate just really lengthy time series, and do FFTs on an entire time series of some length.
Yes.
I can do full complex ones, billions upon billions of points, very fast. If that's what you want to do, I'm sure we can work something out. And definitely I'd want to map it. I'd want to stream this data. If that is what you want to do, I would like to stream this data to a workstation, have a piece of code running there that will, as I mentioned, do scatter gather onto a bank of GPUs, calculate these FFTs, and then take that spectral data into your various analysis, your analytical components of your kernel stack and your display components, because you want to do both. So
we have two. Go ahead, Scotty.
So our architecture is well suited to that, because currently we use a single board computer to do the narrowband DSP function, but since we're using gigabit Ethernet, you can stream it to a workstation also, and put some more horsepower against it, or put a big GPU against it if you're so inclined to do that.
Multiple big GPUs.
Yes.
And actually, we've got it set up so that you can stream to multiple different IP addresses, so you can send fractions of streams to multiple big honker computers and get lots of horsepower.
I think I can help you here. So
the other thing that we would like to be able to do is, some people are not interested. People like Nathaniel are interested in full spectrums. Other people are interested in specific bits of spectrum, the hams, and we'd like to subsample those out whenever they need them.
That's almost trivial to do,
at
least in a mathematical way. Mathematically, it's trivial, but in practice, it might be a little less than or more than trivial. But
you could use an FPGA at the front end to do split out, and then you could do the heavy duty compute in the GPU arrays.
Makes sense to me.
Yes. So the real stumbling block they had to completely get rid of the FPGA was connecting the A to D into directly into the Nano or the Jetson. He did
that in kind of a hokey way too.
Well, he did find a way, a PCIe board that he had an ADD on it, and then he could then just set up the PCI bus as a pipe and then suck that through.
But he started out using the Ethernet as just a dumb pipe with no format, no software formatting on it, just to squirt data across as fast as possible. That's the way I remember his first version worked, how it worked.
Dave has a comment.
Well, his version that he demonstrated actually used an 80D board, just a test board, and a small FPGA board that specifically did, it was a small Altera board that did have some CERDES on it. But at this point, you can't find any boards like those anymore.
He's using the FPGA basically as a PCIe interface, right?
That's absolutely all it was. It was just some glue. Yeah. And he had it wired together. He had the two boards kind of wire wrapped together. So even though they were high speed LVDS or whatever, coming off the A to D board, it worked.
So we should design and build this the way that you want it, at this point. So my suggestion is, who is going to draw the block diagram that expresses that?
Well, probably.
If I'm going to build something, I want to make sure that I'm building what you want.
Well, take a look at the videos on the TangerineSDR website to describe the hardware that we're pretty much is finished. It's very close to being prototype builds right now. So that's not going to change. Now, how we can, since there's an FPGA in it, obviously you can architect that any way you want. So that was the idea, is put the FPGA in there if you want to just use it to stream UDP packets out. If you want to, we got a USB 3 interface on there. If you want to just stream data out and then do with it whatever, you can do that. If you want to do some processing in the FPGA and minimize the processing in the local computer, the host computer, like we were talking about for people who want several virtual narrowband receivers, you can do it self-contained with a Raspberry Pi and our hardware. If you want to do massive GPU processing of the data, feed that gigabit Ethernet or USB 3 out to your massive computers, plural, and arrays of GPUs, whatever you want to do. I was trying to make it so that we weren't limited by the hardware, and you could set the hardware up and kind of configure it however you wanted to do it.
Smart. Good. So I'll look at this documentation as much as I can find. So the LimeSDR documentation plus this GitHub code. I'll look at this.
And for general stuff, TangerineSDR.com is where all of our repositories for descriptions are. I don't know if you've seen that website or not. But...
sorry, I said Lime. I meant Tangerine.
Oh.
Sorry.
Hey, I was going to strangle you there for saying.
Yeah. Sorry.
Which we all have to have a fruit, That's the way it is.
Yes. Okay. Sure. All right. Well, this sounds interesting.
This should give you some ideas of things that have been tried or thought about.
Yeah, because this is kind of like second or third generation after we learned what we did off of HPSDR. So.
Yes, that's why I want to take advantage of what you've already done and the thought processes you've already been through, and just cut to the chase and build what you want, what you need for this. So yes, let me look at the documentation.
Hardware 2 is intended to be Gen 1. I mean, I'm trying to make it as flexible as possible since it's modular. So the idea would be if you wanted a different FPGA engine, or if you wanted to throw that out and put a GPU engine in its place, you could use the RF modules and the clock, the GPSDO clock modules that we built, and their interfaces are defined. So you can build your hardware to use those pieces and not have to go and buy yourself a $2,000 GPSDO. We've got a cheap one that works just as well. Or the RF module. We have one that is likely to satisfy your HF needs, even though you might want to process the data completely differently than what we do and how we do it.
Sure. So I have looked at the schematics for the Jetson Nano on the NVIDIA website, and there I even have the part number. And what they did was they integrated the Maxwell GPU fabric with a 4-core ARM. Now the and I presume that there's a part number on it. I presume it's available from NVIDIA, but I'm not necessarily sure I want to do things that way. Number one, the Maxwell GPU is pretty small, even though you can do a lot of stuff with it. But FPGA might actually, if we're going to do what we're talking about here, and that is basically packetize the data and then send it across gigabit Ethernet to a workstation and do where we can do the heavy lifting. The FPGA makes a lot of sense in that in that case. And given this,
and also
go ahead.
The next generation is planned for 10 gig E. So you'll have a much bigger pipe to deal with. So, and I mean, currently, I mean, you can't really, no, except for really high-end computers, nobody can eat that much data so far. But that goes up every year. So,
well, without a GPU.
Even with a GPU, it's expensive. You're going to want to have an array of GPUs to eat 10 gig of data, right?
Yeah, not necessarily.
Sure. You can also use a cluster. I mean, for this, I can assemble.
But it's not going to be a Raspberry Pi, okay? I mean,
no. No.
So we're trying to satisfy a really broad range of applications. So that's where
I see that
gets gnarly.
Well, let me go through this. This sounds really exciting, actually. Let me go through this data, and I'll probably have some more questions. But it really sounds like I might be able to do something for the project. So,
well, thanks for speaking up.
Yes, welcome.
Well, the truth is, I've been sitting on this technology, and I've been wondering for 10 years what to do with it. And you know, there's some really powerful theory behind it, but I couldn't find any corporate sponsors for it. Most of the time, they didn't know what I was talking about. The people, the ELINT people, electronics intelligence people, they understood.
So what you're going to have to do, JB, is do it and show them.
No, I don't need to show them anything. I'll show you guys. I'm just going to publish.
People.
Oh, right.
Who are non-believers.
That ship has sailed, sir.
Yeah. Well, we're all open source here, so that we'll show them.
But the other thing, think about the kind of ham radio you want.
I can do a lot of thinking there. It exceeds my budget.
That's the real question, though, because my business partner is always telling me, well, why do you want to do that? Why do you want to have 10 virtual receivers? And I go, well, because I can. Well, that's not a really good answer. And I think there's a lot of things that we can do that we don't really know why we want the technology yet. And we could, because it was not possible before. So now that it is, well, how could we configure it to make best use of it? And so that's where all the cool thinking is coming in, is like, well, what would my ham radio look like in 2050? You know, my ICOM or my Kenwood, what would it do now that it doesn't do that we could do with this technology?
Well, to bring this full circle, what we're doing here is it's basic science, really. We don't know what we're going to find. And so it occurred to me that it would be very useful to be able to do spectral analyses on arbitrarily large time series.
Yes.
And I believe that I can take a huge step in that direction with your system that you've already designed. Yep. So my guess is at this point, we're going to keep the FPGA and we're going to stream the data out.
Yes. It's probably a good place to start.
Yeah,
and then for us Luddites who want virtual narrowband receivers, we can have those too.
Of course, we can make it on the receive side, it can be a server. You can accept data from multiple data sets, and there's, once it's in a workstation, I mean, and you have i7s and i9s, those are very powerful multi-core engines, and whereas the 4-core ARM on a Jetson Nano, I mean, it's basically floor just running OpenCV. but on, you know, on a workstation, that's going to open up a lot of power.
And that was one of the reasons that we really didn't focus on trying to use an FPGA with a processor in it.
SoC, the soft
because,
processors,
because when I can buy a Raspberry Pi class computer for $35 or $50, and every year they get more powerful, and then if you throw that out and hook an i9 up, you get way more power, and if you want to put an array of GPUs in, I mean, you can do all that. So why marry yourself to one part that costs more than most of the solutions do?
Absolutely.
And then it's obsolete in a couple of years.
Absolutely. So, you do not want to do that. And FPGAs, the big ones, very expensive.
Very expensive. So they're pretty prohibitive.
Yes.
In our market, it's pretty prohibitive. So
say I have to go. I'm going to say 73.
I need to go too. So
I'm excited. Oh,
good.
I want to show you guys something. This came in the mail today. Let's see. Can you see it there?
Oh,
Delta 60 Alpha Charlie.
Yes.
So tell me where that is now, D60?
Komoro. That would be the east coast of Africa.
Oh, nice.
Cool.
Wow.
Yeah. I managed to catch them on their de-expedition. So
well, congratulations.
Awesome. Thank you. Happy about that. Drool on that.
Yeah. Okay.
I'm excited.
Right.
Thank you.
Thanks, everyone.
Thank you, everybody.
Thank you.
We'll see you next week.
7-3.
7-3.